Good morning, everybody. In this talk, we'll introduce what is OneAPI and what does it have to do with ONNX. Okay, so I guess to answer the question of what is OneAPI, maybe I'll just give a description of the problem that we want to solve with OneAPI. Intel built several xPUs. The X can represent C or G or V, and this is to meet the requirements of different types of apps and workloads. And the different architectures of these xPUs present a challenge to developers. I mean, it's great to have all these different devices and their strengths for different apps, but with these many heterogeneous devices, developing for them is challenging. And to develop your code, the apps optimally, it's even more challenging, right? And also the other thing is not just XPUs, but with every new generation of these XPUs, there'll be new instructions and new technology. That means that if you want to keep updating your apps or your workloads to be able to use these new technology, you have to constantly be updating your code. So development cost, time, and effort will grow very quickly. So OneAPI was conceived to alleviate some of this cost and effort. It won't completely remove 100% all of that, but it will lower that cost and the effort and time needed to develop code for each of this XPU. So it is a unified API where you just ideally write your code once and be able to deploy your apps to multiple devices. And for the new technology that comes up in the new generation of devices that Intel will release. So in OneAPI, various components is sort of a suite of tools, of libraries, and I will highlight a few of them which are more relevant to deep learning frameworks. One of them is the OneAPI DPC++. It's sort of the programming model or programming extension to be able to do data parallel programming in C++. The other one is DPLs. So that's the corresponding library for the C++ library that's also written for parallel code. It's a library for it's sort of like the STL, but for parallel programming. The other one that is relevant, I think, to ML apps and ML workloads is the OneDN. So it's a library that is written that has primitives that support the different ops that are found in deep learning topologies, deep learning graphs, such as convolution and MapMol. These are highly optimized for kernels. And another one, I guess the last one I'll highlight is the OneCCL. It provides primitives for communication patterns that occur in deep learning applications, so that this can be used to support scale up for platforms with multiple OneAPI devices or scale up for clusters with multiple compute nodes. So I'll drill down into more details about OneDN because that's what is, I think, very relevant to ONNX and ONNX runtime. OneDN library is a collection of optimized primitives or ops used in executing deep learning graphs. And we think that this library can improve developers' productivity and enhance the performance of deep learning frameworks. This library supports key data type formats that are used in deep learning, such as FP16, FP32, bfloat16, and int8. And it implements a variety of operations that are computationally intensive and prevalent in DL graphs, and such as convolution and matrix multiplication. Intel has added deep learning instructions such as DL boost in the Cascade Lake CPUs. OneDN has implemented ops like convolution and matrix multiplication using these new instructions. It will also support the AMX instructions that will be found in the Sapphire Rapids CPU. So apart from CPU, OneDN also supports GPUs. And another thing that OneDN does is that it can reorder data into blocked formats that are more optimal for the different microarchitecture of our different XPUs. I think the key objective of ONNX, as I understand it, is to offer interoperability and hardware abstraction. That means if you have an ONNX model, you should be able to run the model on a variety of hardware. This goal is very well aligned with OneAPI. OneAPI is to abstract away that complexity of programming to not just one XPU, but potentially several XPUs. So Intel has built DL acceleration technology into our CPU, into our GPU, and will continue to do so in the future. To run ONNX models using these accelerators require writing code in the runtime for these accelerators. And OneDN did part of that work for us. We have to integrate, and what we have to do is integrate the library into the runtime. And in our case, we're integrating that into the ONNX runtime. So we have done, so this is sort of an ongoing work, and we have done some of that. Some of the features have been added, more features we added into the OneDN runtime execution provider in ONNX runtime. So last year, there was support for 32-bit FP32 floating point data type. It was supporting inference. It was supporting convolutional network as well as CPU. It did not have GPU support at that time. We added GPU support, and currently we're also adding support for NLP, basically ops, in the execution provider for NLP transformer models. And we're also adding support for training, since ONNX is beginning to support some training ops as well. And we're also beginning to support int data types and potentially other data types as well in the future. So that's where we're at today, and we'll continue to develop features and optimize the OneDN EP in the ONNX runtime. That's the end of the talk. Thank you.
Thank you, Kiefer. Any questions for Kiefer?